Hello my dear students, here we are in our physics class. Are you ready? Okay, today we are going to start a new chapter, okay, about simple harmonic motion, right? Okay, just straight away we can move on to our objectives and all. See our objectives: oscillatory motion, harmonic oscillations, then comparison of simple harmonic motion and uniform circular motion. Okay, these are the things we are going to study today, right? So, about this motion, when we are studying oscillatory motion, harmonic motion, about various types of motion we are going to deal with. Then related to the motion, what we have studied in our smaller classes, just recall. Yeah, what all things we have studied? Yes, types of motion. Okay, so while recalling what you are getting, different types of motion we have studied, then periodic motion. Okay, then periodic motion. Here I will show you a periodic motion, right? Yeah, what is periodic motion? Yes, it is completing within the same duration of time, or it is motion which is repeating after regular intervals of time. That is what is periodic motion we have studied. But our first learning objective was oscillatory motion. That also you have studied. See, what is its difference? Oscillatory motion, yeah, the same thing, but about a fixed point it is undergoing to and fro motion, right? Periodic motion itself, but it is about a fixed point undergoing to and fro motion. So, this oscillatory motion also you have studied. What is meant by displacement of oscillatory motion you have studied. What is it actually? Yeah, from the mean position, what is the maximum displacement, that is called amplitude, but in between anywhere it can be called as displacement. That means the deviation from that central point is called displacement, and that maximum displacement is called amplitude. And see, oscillation, okay, for one complete oscillation how much time is taking? It is called time period. All these things you have studied, no? Yeah, frequency also. What is frequency? Number of vibrations in 1 second is called frequency. So, about oscillatory motion, all these you have studied, right? Now, it's another category there. See the next picture. See, about a fixed point it is moving back and forth, going up and coming down, right? Going up and coming down, and see that variation can be shown with the help of a sine wave, isn't it? Why it is called sine wave? How do the sine function is changing its value? You know the sine function's value. Sine 0 means 0, right? Then sine 90 means 1, okay? Sine 270 means, no, so it's after sine 90, sine 180. Sine 180 means again 0. Sine 270 means minus 1. Likewise, the value varies, and that can be pictorial manner we can show by using this sort of wave. So, this type of wave is called sine wave. That means oscillations itself, that oscillations we can represent by using certain trigonometric functions or harmonic functions. So, this oscillation can also be called as harmonic oscillations. Okay, oscillations which can be represented, whose displacement can be represented using harmonic functions like sine function, cosine function, etc. Simple harmonic functions, it can be called as harmonic oscillation, or simple functions there, only sine function or cosine function, or sine and cosine together. Likewise, simple harmonic functions there, it can be called as simple harmonic oscillations. Okay, simple harmonic oscillations. See the next picture also. Simple harmonic motion means exactly, see, it is I said simple harmonic motion means in terms of sine wave we can represent, but see, it is exactly like a circular motion. Starting from x, when it is reaching y, 1/4 of the wave is covering. Okay, when it is reaching at the opposite extreme of x, 180 degree is covering, half of the wave is covering, right? While coming back to x, one complete wave is covering. That means simple harmonic motion means motion which can be expressed in terms of sine function or cosine functions, or generally harmonic functions. How? It's a displacement. That means in a uniform circular motion, when a particle is undergoing in a uniform circular motion, see that circular motion, that black color is particle undergoing uniform circular motion. So, when that black particle is undergoing uniform circular motion, at the same time when we are drawing a perpendicular to the vertical axis, that red one you see, how do the perpendicular moves? So, when a particle is undergoing a uniform circular motion, how do the perpendicular moves? That is representing simple harmonic motion. Okay, when a particle is undergoing uniform circular motion, by the same time, how do the foot of the perpendicular moves? Okay, that indicates simple harmonic motion. Understood? From the starting point, when it is at the starting point, it is at the main position. When it is moving at certain distance away, from the center certain distance away, that means its foot will be, that red color spot, foot will be certain distance away. That is called the displacement. Okay? Okay? If theta is the angular separation, at any point P, theta is the angular separation. According to the formula, angle is equal to arc by radius. If the radius of the circle is A, we can write it as xp, arc divided by radius. Okay? Or in terms of velocity, it is angular motion. So, the velocity can be called as angular velocity. Displacement can be called as angular displacement because it is angle wise movement. Therefore, when we are writing velocity, instead of v there, we can use omega here, small letter w, like angular velocity is equal to angular displacement by time taken. Okay? In circular motion, we can write angular velocity omega. Compare linear velocity and angular velocity. Angular velocity omega is equal to angular displacement by time taken. Or theta, angular displacement can be written as omega into t. Angular displacement can be written as omega into t. Clear? Now, by comparing these two lines, parallel lines cutting the transversal, so this angle also we can mark as Wt. So, when the particle is covering a distance x to p, by the same time its perpendicular is moving from the point O to p dash. That means y is the displacement in simple harmonic motion. So, that displacement y we can represent, see, by using this triangle OP dash P. Here omega t is the angle. Okay? When we are calculating sine of this angle, sine omega t, opposite side by hypotenuse. So, when you are calculating sine omega t, opposite side by hypotenuse, that is radius of that circle, or displacement y can be written as a sine omega t, that is simple harmonic motion. When a particle undergoes uniform circular motion, at the same time how do the foot of the perpendicular moves, that is called simple harmonic motion. Then displacement in simple harmonic motion y can be expressed as a sine omega t. Okay, a sine omega t. So, as the particle moves, displacement also varies. When omega t becomes 90 degree, then sine theta becomes 1. Displacement will be equal to radius of the circle. right? So thus by comparing with circular motion we can get the expression of displacement y is equal to a sin omega t. Clear? Yeah, so we were talking about simple harmonic motion, means this is called simple harmonic motion because in terms of harmonic functions we can represent it. How we are getting these equations now you understood, by comparing with circular motion, uniform circular motion. Now here itself, now always we are taking the measurement from the mean position. Okay. Now whether if the particle is starting not from x, when we are taking the counting from a point P1, okay, a point P1, actually we will be measuring the angle from the starting point, but when we started the observation we are counting from, not from the mean position, some other point away. In such cases, if we are starting from another point from than the mean position, if we are starting our measurement any point other than the starting point, mean position, then we used to say it is having a phase difference. If there is any difference between the starting point and the mean position, starting point and the mean position, that itself is called phase. Okay, phase, P-H-A-S-E, phase in simple harmonic motion. The difference in angle between the starting point and the mean position. Okay, if it is below the mean position will be, angle will be, phase will be omega t plus 5. Okay, no, omega t minus 5, it has to be subtracted, will be calculated. If it is starting from a point x dash, total angle within the time t it will be covering omega t. So when we are measuring from the mean position we have to subtract this additional angle. So phase difference can be either plus 5 above the mean position or minus 5 below the mean position. Okay, above the mean position is the starting point, means plus 5. We have to add that also, then only total difference between the starting point and the mean position is getting. Okay, total angle which is covered will be how much is covered already plus what is the difference. So if it is above the mean position means phase difference is positive, below the mean position means phase difference is negative. So related to oscillatory motion, so many terms we have studied: displacement, then time period, frequency. Along with that another new term is phase. With this diagram it will be little more clear. See the diagram? Yeah, instead of starting from B, it starts from P0. Okay, and that angle is shown with a symbol phi. That means phi is the phase difference here. So when we are calculating the total angle in the expression of y, sin omega t becomes omega t plus phi. So phase difference is positive here. Okay, see the next picture. If it is below the starting level, okay, initial point is below the mean position, then when we are calculating the total angle, this difference should be subtracted. Therefore, the displacement will be a sin omega t minus phi. So phase is indicating position of the particle. Okay, positive means it is starting above the mean position. Negative means it is starting from a point below the mean position. Okay, so this new term is something new to you. Right, now we have studied about phase. Okay, phase difference can be starting from the center itself means phase difference is 0. Above the mean position means phase difference is positive, below the mean position means phase difference is negative. Okay, right? Now another thing, angular velocity. Angular velocity is equal to angular displacement by time taken. Okay, angular velocity is angular displacement by time taken. Here also one more modification if we are doing. If the velocity is, while taking the velocity, angular displacement theta, in this diagram you can see if the displacement theta is at any point, this is the angular displacement we are showing. If theta is the angular displacement, Okay. Then omega, velocity is equal to displacement by time. Just imagine, it is covering one complete circle. Means angle theta will be 2 pi radian. Okay. Angular velocity, distance is 2 pi radian. Then time will be what? Time period. Another formula. Angular velocity is equal to 2 pi by time period. But what is 1 by time period? Frequency. So it can be also written as omega is equal to 2 pi into f. Or instead of f we can use n. Omega is equal to 2 pi n. These are various formulas we have to study. Okay, omega is equal to 2 pi by t, omega is equal to 2 pi f, or instead of f 2 pi n. Okay, these are some of the new things we are studying here. So we are going to wind up today's class. What all things we have studied today? Oscillatory motion we have seen. When it is representing in harmonic function, it is called harmonic oscillation. Then simple terms of harmonic functions are using can be called as SHM, and we have compared SHM and uniform circular motion. Also some angular velocities and various formulas, and specifically phase also. Okay, so we have to study all these things. When you are studying, please you go through it 2-3 times, you read this phase and all. Okay, because it is something new to you, right? And after that, please answer these questions. Some simple questions I have attached here. Go through that and answer all these questions. Okay, likewise complete this topic we have covered today. Okay dear students. Okay then, bye. Thank you all.